Welcome back. We've been talking about data representation. Much text-type information on computers is encoded as ASCII. ASCII stands for American Standard Code for Information Interchange. It was designed as a way to standardize computer character codes among different varieties of hardware and software. When a key on a computer keyboard is pressed, say the letter M, we would expect all computer systems to display the letter M on the monitor screen. When the letter M is sent to the printer, we would expect the letter M to be printed. This is a table of common characters and their ASCII codes represented in hexadecimal. For example, the lowercase letter M in the lower right-hand corner is 6D hexadecimal. The uppercase letter A is 41 hexadecimal. The ASCII system was a great attempt to standardize the computer coding system, but it had limitations. For this reason, the extended character set was introduced by IBM for the PC. It has since continued to be used by compatible machines. The extended character set must be used with a compatible software system or unexpected characters are generated. However, the standard form of ASCII does not allow for such common requirements of word processing packages such as bold, italic, underline, or variations in fonts. ASCII was meant for symbol compatibility used for basic data files. ASCII is still used today, especially when data needs to be transferred between two different software programs. Data is stored as bits, bytes, and words. Bits, bytes, and words are basic computer units of data based on the binary number system. The term bit is short for binary digit. A bit is a single binary unit of 1 or 0. A byte is equal to 8 bits. Early computers processed data in patterns of 8-bit bytes. A word is the total amount of bytes a computer can process at one time. Consequently, the length of a word can vary from computer to computer. For example, many computer systems process 8, 16, 32, or 64 bits at one time. An 8-bit machine would process 1 byte at a time. A 16-bit machine would process 2 bytes at a time. A 32-bit machine would process 4 bytes at a time, and a 64-bit machine 8 bytes at a time. Computers are often compared by the size of the word they can process. This microprocessor is an 8-bit Z80 first introduced in 1976 and still used today in many embedded applications like consumer and industrial electronic devices. This processor is an AMD 64. It is a 64-bit processor. Like the Z80, it is a general-purpose processor. It can do some jobs about 5,000 times faster than the Z80. Both of these processors can do the same types of jobs, but the 64-bit machine not only runs at a much faster rate, it can process more bits at a time. In general, a machine with a bigger word size can do work faster than a processor with a smaller word size, depending on the nature of the job. But not every application of computers, especially embedded or built-in computer applications, require the massive power of something like an AMD 64. Here is a small 8-bit processor called a microcontroller that is very popular today. It is called a PIC processor. It is a complete computer on a chip that costs less than $1 and can control 12 digital inputs and outputs. It is less powerful than the venerable Z80, but is relatively easy to program. This is an even tinier version that can control 6 digital inputs and outputs. It costs 50 cents. Microcontrollers like these are found in all kinds of commercial, consumer, industrial, medical, aviation, and electronic equipment. A class we offer here at Modesto Junior College, called LTEC 214, Introduction to Microprocessor, studies microprocessors using this friendly little computer called the BASIC stamp. It is readily available at stores like Radio Shack. It is very easy to work with, and it is a great way to learn about digital and microprocessor technology. On the other hand, the latest computer games employ some of the most powerful processors available. Game computers like this even use more than one processor. Graphically intensive games require the massive power of 64-bit processors to compute the images quickly enough to make the game realistic. Thanks for watching.